This question is about sample spaces, and they've actually drawn one up for us here. So we are spinning the spinner once, and we've got all the outcomes along the top, and then we're doing it a second time, and the outcomes are along this left-hand side. And then we're interested in finding the product of the numbers, which is to multiply them, and that can give us all the different outcomes. So it's just a case for this box here of doing 1 times 2, and similar for all the other ones, and we can fill in this table like so. Okay, we can check there's some filled in already that work, so that's great. This can be exactly the same as the row above. Here I've got 3. Finally, 4 times 1, 4 times 2, 4 times 2 again, 4 times 3, 4 times 4. So that is it. Now, why is that useful? Because now if we're interested in the probability of something, how many different events have we got? And actually, we have got, these are the outcomes that we can get. So there are 25 different outcomes. Now, it doesn't matter that we've got 4, 5 times. These are different outcomes because here I had the 4 and the 1. Here I've got a 2 and a 2. So they are treated separately. But the number of outcomes is going to be 25. Now, how many? Multiple of 3. Well, let's just go along each row. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 of the outcomes that are multiple of 3, and that means the answer is 9 over 25. Because when there are each outcome has an equal opportunity of happening, then the formula is that it's the number of outcomes you're interested in divided by the total number of outcomes. That's in contrast to, say, a football game where you might win, lose, or draw, but each outcome is not equally likely. It's not necessarily the same, the probability of winning as losing. So you can't say it's 1 over 3. That's a bit of a misconception in probability. So make sure you know the difference. Each outcome has to be equally likely to happen to be able to use this kind of formula. But if you have 2 things going on, then the sample space works really well, and we can work out probabilities like this that would be quite tough to get otherwise. Second part of the question. So Ciara makes a different 5-sided spinner. She spins it twice and records the product of the 2 scores. Now we're told the probability that the product is negative is 0.48. Now that is not looking nice. That's quite different to any question I've sort of ever seen on sample spaces. We're basically being told something like, it's 9 over 25 to get a multiple of 3 and having to work back to the spinner. But it's not quite as complicated as a multiple of 3. We've just got to think about how positives and negatives multiply together. Now, how am I going to get this 0.48? Well, I know, again, there's going to be 25 outcomes because I've got 5-sided spinners. So I think the best thing to try and do is work out the number of outcomes that are going to be negative. So I can write 0.48 as 48 over 100. And then I can divide top and bottom by 4, and that's going to give me 12 over 25. So I want 12 negative outcomes, and that's going to mean I want 13 non-negative. Okay, we just got to come up with the numbers that that's going to work for. So I think at this point it's just a case of trying to make it work. Let's just write down 1, 2, 3, 4, 5. Now that means we have to write 1, 2, 3, 4, 5 along here as well. This isn't going to work because at the moment they're all positive. If I was to make them all negative, then again, I would get them all positive in the middle. So it's got to be this interaction between positives and negatives that's going to do it. So if I make this just the first one minus, what will that do? Suddenly, we'll get, this is negative. I'm going to get 8 negatives here and 8 negatives here, but the rest would be positive. Sorry, 4 negatives here, 4 negatives here, so 8 in total. So that's not going to quite be enough. So what if we try and make that one negative as well? Then I'm going to get some positives here, but then these will be negative. I think at this point I just got to try and see if it works. So that's going to be positive, positive, but then we're going to get negatives. That's going to be positive, positive, but then we're going to get negatives. But then it's going to flip around. Negative, negative, positive, 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 negative, 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 negative. Okay, how are we doing then? So we've got 9, 10, 11, 12, 13 that's a positive, and 12 that's a negative, which is exactly what we want. So that is going to work. And I hope you can see how I did it. So I kind of got it over 25, and then I started just thinking about different ones it could be. It doesn't have to be these numbers at all, but you are going to need 2 to be negative. Now, what would happen if 3 were negative? So if I, for example, switch these around to be negative and switch these around to be positive, then I think it would be exactly the same, because I'd be doing minuses times minuses, and these would stay positive. I'd be doing positives times positives, these would stay positive, and I'd get the same here. So I think you can either have 2 negatives and 3 positives, or 3 negatives and 2 positives. That will work. As soon as you have like 1 negative and 4 positives, that's not going to work. I showed that you had 8, got 8 negatives in that case. So yeah, an interesting interaction that's coming out. I like it. Right, so one possible answer would be what I've got: -1, -2, 3, 4, 5. But as I said, as long as you're putting numbers in, and they could be the same number, couldn't they? I don't think you want to be putting zeros in. I think that will mess it up. So that's one possible answer to this question, with a few other, like lots of other possibilities, but make sure you've got 2 negatives, 3 positives, or 3 negatives, 2 positives.